My talk is going to be about Big Orange and the use of the Jetson Nano new object detection live uh, system or framework called Nano Owl. And you can see a quick sort of demonstration in this video or GIF, whatever, where you can enter text in this box in even a hierarchical way, and the model will detect those objects and give you and in a hierarchical form, and it will and this demo draws the boxes around them. So this is a great tool for a robot to. I thought this would be a great tool for extending the object detection from a set list to a much bigger list, or what we call open vocabulary. So to go back up for beginners or for people who are not familiar, object detection is a major use case for AI neural network machine learned models. And the basic concept is you train models to with many pictures of these objects, and then with sort of human annotation or in a giant data set or captions from the internet with pictures. Then eventually you after you've trained the model when you run it will give you the coordinates of on the screen of each object and a number representing the confidence in the model, how sure it is that this object is in fact what it's labeling. So in the past, and this one in fact is YOLO, you only look once, or yeah, you only look once, and it's the YOLO framework model has been around for many years, that's why it's an 11. And it has a set list of objects that they train for. And this is built into several cameras, AI cameras like the OAK-D and Husky Lens and other ones that will have a set of 60 objects. Usually it's 60 or 80, I think, yeah, 60, the YOLO framework, and they improve it every year, but they really don't add, I don't know if they're really adding new objects or not many. It's only a certain number of objects. And so that's been a very useful tool and system. And that I've been using that on the robot for a while through the OAK-D camera, which has this built-in, this YOLO, or not built-in, but essentially you can load up a YOLO model into the OAK-D camera, and it runs the hardware. So that's really a big advantage. It doesn't take your CPU or your GPU. So what we're talking about here is, and I'll give a brief, I should put this one over here, but a brief description of what it is. The OWL Vision Transformer is it's an open world localization, which means that well, I mean, I don't know. The open world is it's sort of generalized, and then this open vocabulary means you can use any English words and of object names to the model, and it will be able to recognize a great number of those. Not every single one, but a lot more than if you trained specifically on objects that you chose from a list or with a set of pictures. This is trained on internet images all over, of everything. And that's why I just kind of covered this information here about YOLO. YOLO is a traditional model, and it only can detect classes in the training set. The difference is the OWL can detect any object it is never explicitly seen during training, provided it's described in text or provided as a visual example. So it's combining text with image and mapping both to this high dimensional vector space, let's just call it, big long set of numbers. And so you type in a piece of text and it maps that somewhere, like a blue coffee mug will map to a particular point. And then if you have a picture of a blue coffee mug or a red coffee mug, that's going to also be broken into tokens and then mapped into this high dimensional space in a long vector. And then the text and the distance between the text and the image vector, whatever, that determines whether it's going to be a match or not. But this, I won't go. Well, we can come back to that for if you want to go into more detail. So in what I'm going to demonstrate here, in fact, we should just play a video here to rev things up a bit. So this is Big Orange using this tool, and also computing depths as well. So maybe before I actually start the video, I want to show you the second part of what I'm doing is, besides detecting an object, then I want to know where is the object. So if I have a bounding box, then I want to also find out where is the object relative to the robot or camera. And the OD camera that I have, along with many other depth cameras, can compute the location in 3D. This is a depth map. This is computed from disparity between the left and right cameras, and with a pattern matching, it can then extract the depth of the object or of the pixels in this frame. And so this box here is showing you, and the Z distance is kind of the most important, and the color, and you can see as it gets farther away and closer. So what I want to do is take this nano owl, or this owl detection, and then pipe it through the spatial calculator on the OD through its depth map, and then it will give you the location of that object. Now, the OD comes with YOLO, so it can already do this all with YOLO objects built in, but it can't do it with any other. It can't do it with the wide variety of objects you can find with the owl.
Hey, Jim,
Any question?
which oak do you use? I mean, which YOLO?
Well, on my OD, it's only like YOLO 9, I think. Now it's not the latest, but
I was considering YOLO.
YOLO is fine, but YOLO is limited to only 80 objects or
So
6.
the new one is unlike.
The YOLO is it YOLO 11? It's still, YOLO is still limited. Well, let's look. I haven't really looked, but generally YOLO is, let's see, greatest YOLO limited.
YOLO's fancy compared to him using Green Dream. Slots for.
Yeah, the YOLO 26, 11, and 8 are limited. In other words, they're only trained with this certain number of objects. You can add them yourself, but you'd have to train it. Yeah, they're trying to make it better, but it's still, it's not even giving me the number. Uh, how many? Yeah, 100 to 300. So yeah, there's a not a hard limit, but it's not open vocabulary. That's the big difference. And as you can see, this is live. This is live. It's real time using the OWL system. So now let me just play that video of whoops.
Yeah, we were talking about with the can contest. I think the basic YOLO model has like a few, but it would be nice to have a dedicated trained model. I think
Yeah,
someone at home group it did a trained model for
you
it.
can train YOLO yourself.
Yeah.
But it takes you. You have to take your own pictures, hundreds of pictures, and I really don't relish doing that. So I'm switching to models that just do it. The new way is just use models that do it for you. So like here, let's go with this.
Hey Orange, search for a ball and approach it.
I'll rotate and scan the area to search for a ball, then move closer to it if I find one. Let me get started now.
So here's the full integration of.
I found a ball at a nearby position, so I'm going to approach it now. I've moved to the ball's location and am right next to it now. If you need anything else with the ball, just let me know.
So that is the integration of the full system with navigation. Obviously, robot has mapped the room and stuff, and through its lidar with SLAM, and this just rotates the robot around, and then when it sees the object you want, it then maps the depth. And so yeah, now let me get it. Maybe I'll play another video here, which before let me check where we are.
Why did you bring orange today?
No, I didn't.
Why not?
My neck is out of commission right now.
All right.
Here's a little bit more detail on what you can do with this model. You can, if you see here, there is the prompt. Whoops. Oh, I just. You can actually put a you can put down. You can actually put descriptions of like the colors of the object in like in parentheses. So this is a higher level. You can actually add what they call as classifications. So here they've added like black, pink, blue, and green, and then the model will not only look at the object, find the object, but then it'll classify based on the color, and then tell you the color there. I don't know if you can see that, but I haven't gotten quite to that level. I'm almost there.
Is it do they train different color markers with the color as part of the name, or is it color detection separate from?
No, that I mean, I haven't looked into exactly basically it's a sub classification. You could just say red marker without the parentheses, and it will because again it's mapping that text to an embedding space, and it maps pictures of markers to embedding space. So as long as somebody somewhere in the internet had markers, and it could cross, the system was trained on all these pictures, and so eventually it's going to get the sense of color because the color has been annotated, written down. This is these are pictures with captions.
Right.
And so it eventually learns what a marker is, and it learns what red is. And even though it never saw a red marker, it can identify the red marker, even if it never saw it, because it's trained both of those things in parallel and orthogonally or separately in a way. That's the nice part about this model. So if you're interested in depth map, this is basically a depth. You probably you saw that in the video, but you can see the close object is the brighter color. And we can even do some enhancement on that. So now let me show you, I think it's this video here.
Hey, Orange. Track the...
What I'm going to show here is the beginning of the implementation on Big Orange requires me to track the ball as it's moving or as Orange is moving, right? So it needs to be fast. Now, one of the challenges to this project was the camera is plugged into my main PC, right, for the single board computer, and the processor doing this AI is the Jetson Nano, and I have to send down these images, and so I had to, rather than at first I just plugged in a separate camera into the Jetson Nano, and but I don't want to have two cameras, so the main camera here is the Oak D, and you can see this white box is from YOLO, which is I always have running, whereas the green boxes you'll see are from the Jetson Nano from the OWL. So I take these pictures, send them down to the frames, I should say, down to the Jetson Nano, and then the Jetson Nano sends me back
ball that is already in your view.
I'll start tracking the ball at eye level again for you.
No, this is on board. Yeah. It's Jetson Nano plus the single board computer that which is the Latin Panda. Yeah, you can see this is an improvement over my last one, but it's able to, even though it's sending down that video to down to the board, down to that Jetson Nano, and then getting back info, it's able to keep a reasonable rate. And let me show another. Here's another video of kind of the general capabilities of the model. And what I've done here, this is running through my robot. It is doing the same thing you just saw, except now I've got like a debug window here where I'm not running the full robot system. I'm running like a test program. I can type in the names of objects, and it will send it to send the text down to the Nano OWL. The Nano OWL will send back boxes, and then I send that to that calculator I told you about, the depth calculator, on board the Oak D camera, and then so I compute the depth. So you have to have these two pieces. It's a coordination of these two devices to get the depth information.
So here I have a sample program that is allowing me to type in prompts to Nano OWL, and it is sending images from my Oak D camera down to the OWL and getting back the coordinates of the bounding boxes, and then it is processing those through the region of interest depth calculator. So this is how we can learn the position of an open vocabulary of a set of objects, as opposed to the limited YOLO. So I can say ball. It'll come up with that ball. I can say vase, and well, it comes up with it'll go back and forth between that lava lamp. I can say lava lamp, and it will stick to that one. I can say even more advanced. I can say weight, say, and it finds the weight, and you can see the distance. I can even do something. Oh, here's keyboard. Can even do something really esoteric. Viewmaster, and it knows what that is. An old toy. Wall art.
This is the OWL VIT.
Oh, that's owl.
OWL VIT. Vision transformer. Oh, I forgot. I can put in Bender, and I didn't do it in this, and it puts a box around Bender. But it also, I think I said dumbbell, and it put a box around it.
See, it's gonna get some wall art. So yeah, it's
in these numbers you're seeing. The third number is the depth in millimeters. So that's what's key for the robot, so that it knows where. Well, that one doesn't look right too. Well, maybe. Obviously, lava lamp is further. That's 2.4 meters away. So yeah, that's what's important here to me as the robot.
I can even do something. Oh, here's what that is. Art. You can see it's gonna get some wall art. So yeah, it makes everything. It makes this capability, gives the capability to find out where many different kinds of objects are, instead of just the set ones. Thank you.
Yeah, so that's that, and now let's see another. Those are those videos. Let's go back. Any questions so far about that? So the overall concept is, and here's the sample code for doing that calculator. You can just, I didn't have to write this type of code, but it will do this for you. There's even one that can do multiple objects tracking across the screen or wherever you want. Yeah, multi ROI. So that's like this one with. You can find out where any of these things are. So the key thing I wanted to do is use this use OWL to find out where where the object is on the screen, and then use the OAK-D to find out where it is in space, and then then you can drive the robot to it. And so here's let's go back so I don't get confused. Here's another one.
You like owl?
Yeah, I mean, it's really good.
It's fast.
It's real time. Like here's another.
Because I've been using.
Hey, Orange. While going to the hall, search for a ball on the floor and approach it.
I'll start heading to the hall and look for a ball on the floor as I go, making sure to approach it if I spot one. Let me get started.
So this is the case where I'm telling it go somewhere and look for the ball at the same time.
I've located a ball on the floor, but I'm not yet near it or in the hall. I'll move toward the ball's position to approach it now.
Yeah.
I've moved to the ball's location and am now right next to it. If you'd like me to do anything else with the ball, just let me know.
But you
Hey,
said you're
Orange.
using YOLO.
Go ahead.
You're using YOLO to get the location, but you were showing OWL telling you the distance. So what additional information are you getting?
Oh, sorry, I might have confused things, but essentially we're using OWL to get the bounding box on the screen.
Okay.
Okay, and then we take that. I get that number. I get those coordinates, and I run those coordinates to the OAK-D camera.
Oh, for the depth. Okay.
For the depth.
Oh, okay.
And
I thought
then-
that was OWL too for some reason. Okay.
Right. No, that's the key thing here is OWL can only give you the coordinates on the screen about the box. And then you take that box and then using the depth camera, asking it in this area of the screen, what is the approximate coordinates? And generally I just take the middle of probably like the middle of the bounding box, for instance, is where you'd want to do it. I mean,
You're getting it for the distance.
yeah, for the distance, not only distance, but it's X, Y, and Z. So then you use some trigonometry on the robot that, based on where the camera's pointing and what the X and Y, the X is the main one. The Y isn't really that important, but the X is where it is, so heading wise. So the robot will then knows, oh, I'm looking at this way. The ball is to my left and 1 meter away, and then at 30 degrees turn. And so that's all computed with your geometry. From these 3 numbers, you can compute that from the robot's current position and current camera orientation. It's all taken into account. And then the last step is if the robot sets a point, a target point on the floor in XY coordinates from its map. And I've had other videos.
So that's its own destination. I like that.
Yeah. So after it computes the location of the depth and the X and Y of the object, then it has enough info now to say it knows where it is. Or it basically says, okay, I need to go forward. I need to go forward like 2 meters, and then at an angle of 30 degrees to get to that object. And then if you just compute the robot's location in X, Y in the house, and then you can use geometry or trigonometry to compute the new X, Y location. And if there's an obstacle, it'll go around it, as usual.
Are you using LiDAR or no?
Yeah, this is LiDAR.
All right. Yeah, I didn't see it.
Yeah, this is Big Orange as he's always been.
Hey,
All
Orange.
right, let's do one more. This is yeah. This one's a little bit funny because he gets a little bit wrong, so everything's not perfect.
Search the floor for. Hey, Orange. Search the floor for a dark green dumbbell and go up to it.
I'll scan the floor for a dark green dumbbell and move right up to it if I find one.
This is the short version.
I found a dark green dumbbell on the floor, so I'm heading over to its location now.
I think I should have said the other one, but there's 2 dumbbells. One, but it ends up going to the light one, but it went to one of them, so
I've
I'm
moved
happy.
right up to the dark green dumbbell on the floor. Let me know if you want me to do anything else.
You don't have one.
No, not yet. I'm thinking
Is
about
that
it.
coming?
Hey, Orange.
Yeah, I want to.
I know you do.
I have one.
You
Yeah.
have one, huh?
It's a little bit frustrating for Orange to come up to objects and not be able to do anything with them.
All right.
So yeah. Any questions?
Yeah, I have a question that you might have mentioned at a previous meeting. What, I noticed it has, do you want me to do anything else? It has a regular pattern language. Is that all like a operating system in the background that's like AI or what's the
Oh, yeah.
language?
I've given it, I think, yeah, I've talked about this before, but Big Orange uses LangGraph, the sort of the predecessor to OpenClaw, and it uses LLM, uses a lot language model, and combined with the LangGraph to direct its behavior, and use tools. So all the things it's doing are using those tools from, your speech goes to the LangGraph. I mean, it gets interpreted by the LLM,
Sure.
and then the LLM knows how to use these tools, and the tools are all described in English. So there's a tool called, search for object, and then so the model, when you say please find an object, it knows to use that tool, and then the
Did you write
tool
that?
runs that. So LangGraph is this framework that is out there,
Yeah, I know.
and then I had to write the
Find-
code that connects it all. Yeah, so I wrote the higher level code for find object, and for my robot, because it's different from people's robots. So my find object code does all these things, that pulls all these things together. It depending on if it's a YOLO, like I've broken it into two. If it's a YOLO object, then I just use the YOLO coordinates and compute from there. If it's not a YOLO object, then I use the nano owl. So then I send the pictures down to the Jetson Nano, and then get back the coordinates, compute the new location, and then set Orange to go to location. But yeah, essentially this kind of you're having a conversation with Big Orange through the LLM and LangGraph, and so it kind of knows its history. It has memory of what you've asked it, and when it completes it, it generates a new response, and that's why you hear it say, "Do you want me to do anything else?" Because it's just like a chat engine, as you're familiar with.
Are you using a llama?
Not, I sometimes do, but in this, I kind of settled lately on just using ChatGPT
All right, so you're going through the
or yeah,
cloud.
I've been doing cloud for that interaction. Although I have because it's a little too beefy to run a good tools LLM capable LLM locally not on the robot. But I have been experimenting using my PC, my desktop computer, and then doing that over the internet to be sort of local.
I've got a llama here. It's pretty fast. I got the smaller model, 3.3 billion or something.
Yeah. Yeah,
That's fast.
well, Olama lets you use whatever models you want,
Yeah.
right? But in
Yeah.
this case, I would have to use, I had running on the Jetson Nano a vision model, but
This-
it's slow and it worked reasonably well. I mean, but I'd rather have that, you just use the cloud or use a cloud local for that, which is, using, my PC with a big video card in there to do that. But for now, it's like it's very difficult to move everything off the cloud, and it takes time and hardware. But for the and you can experiment and see how well it does. But with the tools used specifically, I need a pretty beefy model to really use the tools well. And but this I'm getting some good stuff with this. With the vision stuff, running on the Jetson Nano. Charles, you had a question?
Oh, yeah, just wondering about the OP camera that it uses stereo vision to determine depth, right?
Yeah, it's
So
stereo vision and disparity depth, it's called, and it does pattern matching between pixels of left and right, and then so it's an estimation. It's not as good as, it's not perfect. It has problems
So
But
for
it
the
works.
video feed, you're just looking one eye or the other. The video feed that you bring up, you're just looking at through the camera from the left or the right eye, basically.
Well, the
that's what
video
you're
feed is the
feeding it out.
color, is the middle, view. Like this, we're talking about, like if we go back here,
Hey, Orange,
this is the,
track the ball.
so the OFD, I'm still using, still banking off the OFD after 5 years or something. It's still a good camera and you can explore using it for a long time. But essentially, the OFD has three cameras. It's got left, right, monochrome, and a center color camera. And what you can do here, I'll just OFD. Show the picture of it. So this, what happens, so the stereo is derived from the two left and right cameras, and the color is the, what I generally use for preview. And it knows how to calculate the parallax and essentially plot the correct number. It's called fusion. It does stereo depth fusion with disparity. So all this is on board the camera, and some of the code is in your is running in your Python. But oh, that's right. Did I forget one of these? Oh, let me just show you the. I thought I brought this up. You go to depth AI, and then ROI. Oh, I had it up, didn't I? This one, the spatial locator. So, right. So so you're seeing what it's doing here. It knows how to. It finds. It does the disparity calculation, finds the depth and the XY, and then you can plot this over the color image, no problem. So that's why you're seeing.
Hey, Orange, track.
In this case, like we're a little behind there, but you can see that we're plotting the location on the over the color image, but it was calculated from the left and right. Does that answer you?
Yeah, that was very helpful. I was just wondering if Al has has any extension that can handle stereo to determine those set calculations.
Oh, OWL doesn't. The OWL. That's why I have the. Otherwise, I would have used that, right?
We can put L twice, one.
Oh, yeah.
What's that?
We
Oh,
can put L twice, once for each
Yeah.
camera, and then take
yeah,
two bounding boxes, treat to figure out stuff. That way.
yeah.
I don't know if it's any better doing it that way.
Oh, yeah. You could probably do it that. Yeah, you could do it that way. But I already kind of allocate my OFD cameras to the general to other things running on the. Things are limited on Big Orange because I have the. I always have it running, for other things going on in the robot for detections. With the I use the YOLO, mobile net, YOLO running on the Big Orange. So, but yeah, there's other ways you could achieve it for sure, like you're saying. But I found this
And it is all
the best for me
I can
because
say-
I already have all these.
the lamp. I can
have-
say,
I have, the OFD running. I have the frames coming off it. So this is like, unless, this is sort of the minimum amount of work needed, right? Because I just send the picture down, get an inference back, send the coordinates to the calculator, and then get back the coordinates.
Makes a lot of sense. Yeah, I was just wondering if anyone had done anything with OWL to extended stereo.
Yeah, I bet they have. Yeah, well, we certainly, the OWL bit. Let's see, Owl, EIT, stereo. See if they've done anything.
The bounty box tend to be a little jittery, so it might be a little less than perfect.
Yeah, not sure if they've done that, but you can read up about Owlbit. And yeah, so for people that are more interested, it's just a fascinating model because it's in my Word though.
You say you're running that locally?
Yeah, so this is all from NVIDIA. And so the NVIDIA, I highly recommend the NVIDIA Jetson Nano or Jetson Orin Nano.
From
So
NVIDIA.
Yeah, and Jetson Orin Nano. So the Jetson and this NVIDIA Jetson AI Lab is where all these things are, like Nano Owl, that you can use that have been developed. And like last time I showed the lava, where these other videos I won't go into now, but my last talk, you could ask it to describe the room. You could ask it questions about what's on the table, and that's all also in real time. That's called the Nano BLM, and I showed you that in a previous talk.
What's it cost for,
And yeah, the
Jetson
Jetson.
Nano that works with their software?
So this Jetson Nano.
And including, extra memory or whatever it requires.
Yeah, well, you do buy. So this is the Orange Super Kit, NVIDIA Jetson. It's back in availability, and it's only been it's back to normal price of $250. So it's a pretty good device. And then you need to buy some memory. I bought an M.2 SSD for it. $100 something or whatever. Well, memory is expensive right now.
So you're up to 350.
Yeah, I forget. And then you want I think that's basically it.
And power supply is probably going to be about 20, $30.
Well, this comes with its own power supply.
Oh, really?
Yeah, but
That's good.
to hook it to the robot, you need a battery connection. But this thing does 67 tops, and so if you use or if you go this route, they have a lot of these tools for it, or these models that they've ported and fully optimized. So these things run very fast.
What OS are you running
It runs Linux.
on? Linux?
Yeah, it's just like it runs the standard
You run
NVIDIA Ubuntu. NVIDIA is like Ubuntu, which is older, usually older, not the latest. But yeah, anyway, so
I got a laptop. You see?
yeah, I mean, you can run. I mean, I've never put a laptop on one of my robots just because they've been too small for that. But you can use any computer.
Because for 350, if you get the speed for a visual model, I mean, that's great. Because I run a visual model on this, it takes me 30 seconds to get a reply.
Yeah, and you have to. What's the thing about this is a key thing for this type of systems. The NVIDIA hardware is fully optimized for real time and very fast inferencing, and so that they've worked very hard to turn these models from the research into production quality, say, ones that run in real time. And so it's not, you can't use just anything. This is the diagram here, how it works. Chatting and LLM, VLM, and then this is like the full picture. Pictures and text go in, and
What's it drawing about? 5 amps?
and less. Yeah, and the whole thing, that's the other thing. It takes 25 to 35 watts to run the device. So it's very good, very decent for power. But this is like doing in real time, describing what's happening. This requires a little bit more horsepower than the Jetson Orin Nano, and maybe the Jetson AGX AGX, which is for bigger robot. But a lot of these can run on my little 8 GB device. And if you go to this, you just want to browse this web page, you can see they have very clearly indicated which Jetsons these samples run on. And so mine is this last one, the Jetson Oro Nano 8 GB. And several of these can run several of these real-time things, including the lava demo and the one I showed you, the Owl, Nano Owl. They can run on this $250 device at 25, 30 watts, whatever, you know.
Can you run a LLM plus a VLM at the same time on it, or?
No, it's so a good thing to remember what this is. It's only 8 GB, and I could barely run the Nano VLM or the Nano Owl. The Nano VLM, when I was running that, I had to like work on getting the memory situation under control, because it would be out of memory very like quickly, easily, and you'd have to keep rebooting. So I kind of worked with, you know, an AI agent to help me figure that out and get it to fit into memory, and so it will reboot and fit into memory.
What do you use for voice recognition? Is that a separate model, I suppose?
Yeah, the Orange's voice recognition is still using that Boss. I've never upgraded from Boss, which is model that's been around, or a system that's been around a long time for specifically for low power devices and with not much memory. So you can find it on the internet here, Boss. It's pretty good. It's only 40 megabytes size of this model.
It's pretty small.
Very lightweight. It's designed to run on Android. So I mean, I have to do all this for my, for robot, for Big Orange. He needs the fastest, lightest weight, because the CPU power is not very much. It's a Latte Panda, which is an Intel Celeron or whatever. It's not a very powerful computer. And you need the light, and that's where this runs. This runs on the CPU. There is a GPU on there too, but it's just integrated. Okay, I think I'm out of time. Any other last questions?
Oh, cool stuff.
That's a great advances.
Well, thank you. Any?
Yeah, perfect. Jeff?
Oh, we were trying to navigate for so many years. Now you're navigating, finding things.
Yes. And the multinational experiences and the Rube Goldberg competition. And that's a mouthful. I'm sharing my mission. Do you have a mission? Well, I do. And here I share it with you. I can go to the next page. Oh boy, now it's time to. Today I'm going to tell you about two stories: the Power of Yes and the Chinese Trinidadian US multinational robotics competition, the Power of Yes and the Rube Goldberg competition, and then a combined goal for multinational Rube Goldberg experiences that I have created for myself with different nations executing on the same team.
Yeah, put yourself into treasure.
And then we're going to talk about, now that I've said yes, what am I asking you to say yes to help me with? The backstory for the multinational experiences. From 2018 to 2019, I hosted in Long Beach 3 international events. Why? Because somebody asked me to. Some random person from Beijing said he wants to bring his students here to Long Beach. And I said, okay. Students from Long Beach competed with and against students from China and Trinidad. I tried to put them together on the same teams. It was less than perfect, but it worked in a way. My customer was an entrepreneur from China. He found me on the internet because You guys may know I do competitions. I don't know why, I just do them. I made some observations I knew I wanted to change, mostly related to the, oh, you're not seeing it.
You want the password for the? What?
Can I give you the presentation? Access to the presentation?
I didn't bring my laptop, but maybe.
Can I give you, Alan?
Sure.
Okay, sorry. Logistics.
Email it real quick or if it's in a flash drive.
I'm gonna share it. Alan, what's your email?
You can just put it on the email that you sent.
Oh, I'll put it in the chat. How about that?
Okay. Is it online?
Yeah, it's on the internet. My apologies. Actually, and this is my way of giving you the documents so that you can post it if you'd like. So if you click on it, you should have access. Anybody who clicks on it can have it. And then I don't need this, right? If it closes.
Sure. You don't need
Did you get it?
working on it right now.
Okay. Then I'll stand behind you.
Didn't all work. All right, let's switch to Carl if he's ready, and then I'll just hop on the Wi-Fi. All right, we'll get there.
Okay.
So I need some help. Yeah, do you want to go to the bluealliance.com?
So you need me to be on? Okay,
I'm sorry.
Give me. No, it's okay.
Someone
Let me
else.
just hop on the official Wi-Fi. Give me a second.
I can do it too.
All right, if you're already on, okay.
What do you want?
Bluealliance.com.
Share sound video.
Alliance. Face?
Sorry. Maybe not .com. I'm sorry.
.org?
Yeah, just search for Blue Alliance. Yeah. Farsi. I have never run into that. Yeah, there you go.
All right, so yes.
The Blue. All right, so we're gonna click on. Well, maybe it'll be on this list where like something to count for. Yeah. Yep. That's South Carolina. Keep going.
California, Anaheim.
Yeah. That's one. And the result is
I picked them up last night.
here we go. Oh, yeah, so
You never shot.
so look for one that's got reasonably high numbers over here.
484.
Yeah, there's some that are more like 500 and stuff. So, yeah, go from there.
550.
Yeah, so let's click on that. play that video and then pause it and then I'll explain it. So we're gonna watch that video. So you can maximize that.
Where's the maximizer?
In 3, 2, 1, go!
Okay, all right, so I'm just giving an update on the first robotics FRC competitions. So they've had all their like preliminary rounds, and then this weekend is all the state district championships. So California is so big, they split it into Southern California and Northern California. So this weekend is the Southern California State Championship. And it's at the Anaheim Convention Center. It was Friday, Saturday, and tomorrow. And tomorrow they'll do qualifications in the morning and they'll do the finals in the afternoon. So after like 1 o'clock, it's probably at 1:30. It's a lot more fun there seeing that stuff. It's free and open to the public. Parking is $25 at the Anaheim Convention Center. Although you could go to like the Garden Walk and it's like free for the first hour and then $4 an hour after, so if you're only there for a couple of hours. So anyway, I think I talked about this before, but the game this year, there's just a million of these yellow balls, and you get a point for picking them up and then putting them into one of your hubs. So there's two sides. There's the red alliance, the blue alliance. In the qualification rounds, they're just randomly assigned teams. There's 3 teams per alliance. In the semifinals, the top 8 teams are going to pick, from the qualifications, are going to pick their partners. So, but right now, all these are just randomly assigned groups of teams. And there is a tower on each side too, and you can climb it for points. So like 10 for the first rung and 20 and 30 points. But these balls are worth a point each. And so pretty much very few robots are doing climbing. There's a few, and it's impressive when you see it, but so basically, this year, just having all these balls, is complete pandemonium. Each match is about 2.5 minutes. The first 15 seconds is autonomous. So the first 15 seconds, they're going to do. Some of them will just sit there. Some will shoot balls. They can preload them with 8 balls, and then some of them are going to actually go through and pick up balls and come back once or twice if they're good. I've heard there's possibility because they have the fiducials on the goals, so they can actually see the thing. So for example, the team I'm helping, that they have a turret shooter, so that picks up the balls, feeds open the turret. That turret is completely automatic, and they just say fire, and it'll look the able tags and hit the target. It'll project the distance and the direction. So yeah, because they're fiducial, so you know distance and direction from those direct ones. So I was thinking about that when you were talking earlier. First 15 seconds is autonomous. Whoever gets the most points. There's like another 10 seconds where these are both lit up and any side can score. After that, they go, whoever had the most points in the autonomous phase, their goal lights up for 30 seconds and then it switches to the other side for 30 seconds. They go back and forth twice. And then like the last 15 seconds is the thing. So I don't know, just want to watch. This is what's going on.
Autonomous action beginning with 696, 4201, 4414, and 2584, all racing out to the neutral zone in the middle. These robots now taking a second to score into their hubs. We see the scores starting to even out a little bit. Red Alliance with a very slight lead right now, just over 10 points, but it's a second pass into the neutral zone from High Tide and from the
Zoom bar was blocking the score. Okay, that's probably better. Yeah.
Out of their side of the field, though, by defensive pressure from Flame of the West. Flame of the West knows that they can do a lot of work by just keeping 4201 with that giant hopper out.
They just have a thing that shoots them all in one direction. Yeah. They got just a bar.
Hungry hippo.
Yeah. Size, they all pop out to expand the hopper size this year. Yeah.
Of their own alliance zone. 4201 realizing that they can't quite get back in during this shift, so they're going to funnel all that fuel over to their side of the field. Titanium Robotics now is the scoring robot over here on red as High Tide continues to try to collect some more fuel. Here they go now, both Red Alliance robots scoring as much as they can, while Flame of the West supports them, removing fuel from the blue side of the field, bringing it back into the neutral zone, making it easily available and accessible for their alliance partners. 1160 and 4414 doing a great job of scoring for the Red Alliance. They're already almost at the supercharged ranking point bonus, while the Blue Alliance has their sights on that energized bonus. They know that they can still get additional RP from this match no matter what happens with the outcome of the score. So that's what both of these teams are focused on right now. 4201 and 696 scoring at the same time. putting a lot of fuel up into that blue hub. With under a minute left in the match, it's time to turn our attentions to the red side of the field as 44-14's already scoring. 1160 Titanium Robotics, they're scoring as well, bringing that hopper back, dragging it in slowly, putting pressure on the fuel, trying to get them back into their indexer and up and out of their shooter. TNT has something to say about it, though. They're playing some defense on these two Red Alliance robots, trying to push High Tide out of their own zone, but High Tide going to continue scoring anyways, using that creative bumper design to limit the effects of defense from the opposing alliance. Over on the blue side of the field, they're getting very close to their energized ranking point bonus. Here they go now. A big flurry from 4201 is going to put them over that threshold. Red Alliance, though, their sights are on 500 points, and with High Tide on the field, you feel like it's a given, and yes, it is. Over 500 for Red. Blue getting close to 300 now. We're seeing final scoring. These teams just showing off what they can do with some impressive scoring in the last few seconds.
And they're gonna do 3 runoffs?
What's that?
So showing from both alliances here in this match, but unfortunately only one of them can take the 3 ranking points for the win, and it will be our Red Alliance in this match. 551 points scored was going to net them 5 ranking points. High Tide jumping up into...
The blue team got an extra 10 points. So, yeah. Anyway, yeah, they do the qualifications for this final event. It's 2 days where they're just randomly assigned, and then based on when they win or lose, they get a ranking. And then the top 8 teams, after all that ranking is done, they get to pick their alliance partners. So it's not enough. This students are like, oh my God, we just went up a point in the rank, but there's not enough statistical samples in these quals because there's only like playing a handful of games. To really have a true ranking. And the ranking is per alliance, so it's all 3 together. They don't rank individual teams, so it's kind of an aggregate score. So it's not a perfect system, but that's how they do it. So yeah, so Sunday they'll have some calls in the morning, schedule's all online, and then the afternoon they'll do the finals. So, yeah.
Crazy, man!
Yeah, and this one's good. I mean, the other ones are like at high schools and things. And this arena, I mean, that was half the arena, so there's a lot of seating there. So, yeah. Oh. And then after this, the top 43 teams, California has 300 teams. There's 150 in Southern California. The top 60 are at this event, and then the top 60 of 150 are, and there's another event in Northern California. California gets to send 43 teams to the final competition in Texas. So,
Okay.
that will be in the
So you chose the robotics meeting over...
Well, yeah. I was there yesterday, and I'm going to be there tomorrow. And I was like, yeah. So.
Got a day off.
Yeah. We have just enough mentors to not be there the whole time.
All right.
So back to Ellen Dickfall. Okay, here we go.
Hopefully.
Hey, tecnologia.
Yes, and the multinational experiences and the Rube Goldberg competition. Always too much. Let's go. Thank you. Today's speech. Are we sharing like the slideshow? I guess we must be. It looks kind of small. I have to read behind you because it's not me. There are 2 stories. The first one is The Power of Yes and the Chinese, Trinidadian, US multinational robotics competitions. The next is The Power of Yes and the Rube Goldberg competition. And then we have a combined goal. Today's speech, we're going to cover the 2 stories, the combined goal, and now that I have said yes, what am I asking you to say yes to? So some of you guys have been in this club a long time. And partly maybe that's why they came to me, but whatever. I got contacted and I supported this guy from China in bringing students from China, and then I engaged in Trinidad, which is my birth country. And so by 2019, when we had the 3rd event, I had hosted 3 international events. I call them multinational because I kept trying to get the students to work on the same teams. It's really hard for American kids if you might imagine, to get them away from their TV and their phone and their soccer and their baseball to do something like this. But I did it somehow. And I made some observations that I knew I wanted to change. And then we had a pandemic. The thing I really wanted to change is I wanted to get away from country-based competition. I wanted to get to multinational competition because that is collaborative and it's not about going to America and winning, right? And I really wanted to do this. But we had a pandemic. Next. So this is in 2018. I was at DeVry University. Some of you guys engaged with me there before. There's the group, several teams with their coaches. And I did some training and like some networking and collaborative experiences so that we could get some socialization going on at DeVry University also. They were going through a transition, and so I was able to do that. Next. This is also at DeVry University and the same group. I took them to Shoreline Village. Oh, that was a different time, but I took them, maybe not, to Shoreline Village and we did art because you do art when you're not doing robotics. Next. In 2019, we were over at the Expo Art Center. And next. We went to the Downey Space Center. I know about it because of the city of STEM, and they wanted something interesting and low cost. So yeah, next. And in summer 2019, we went to the Pyramid Event Center and had our competition there. Visit to the Chinese consulate. The first summer 2018 one, actually the competition was held here at Cal State at the meeting. I don't know if you guys remember.
Next story.
Next. And then COVID. Okay, next. So then we go back to the second story, my backstory. I love contraptions. You guys have seen me bring some contraptions here, usually related to Lego, but different things. And I have been trying to form a team for a long time, but it was always cost. But in 2021, the cost went to zero because they got a big sponsor. So I took advantage of that and I made a team. I just reached out randomly to whoever I could find on the internet. We did virtual meetings and then we had in-person gatherings where one family at a time could meet. Then I did the Southern California Regional. I did it again. And this year I said, these teams are coming all the way from Calabasas and South Orange County. I want Long Beach teams. So I sourced 3 Long Beach teams, which I'm all closely connected with as coach or co-coach. And then now we have coming up in May, the West Coast National since 2026, first ever. Go. So this is me doing contraptions at St. Bart's Youth Ed Center, at Bayshore Church next, at the Long Beach Sea Base, wherever I could find a spot. Next. This is the virtual team. We were so out of spec for the competition, but it was COVID and who cares? The kids had a lot of fun. We had 5, 6 kids on the team. And I love that module. That is a screw module, and it's made of paper plates and string. Next. First Regional 2024. This team was innovative inventors. They ended up going to the national over in Indianapolis at Purdue University, and they won $1,000 and a giant trophy. On the right, I had made a lot of bunnies, and I gave everybody bunnies. It kind of became a signature thing for that event, and that's great. Next. We had a competition last year at El Dorado Park West. We had 6 teams. The first year, 2 teams. The second year, 6 teams. This is the innovative inventors, that same group of girls. Their competition entry was much more advanced than their first year. So it was kind of amazing, the progress. Next. And then this is the Innovative Inventors this year. They had a whole performance based on Harry Potter, very immersive. It's like performance art meets STEM. I think you called it Steve. So can you click on the link? It is an audio. So I don't know if it's going to come up with the audio. Last time I did this presentation, somebody said, you got to have a little visual, a moving.
Yeah, so no audio, you might just want audio.
So yeah, so what they did is they had this whole Harry Potter immersive script they had written where she is being recruited to go to the Harry Potter, to their school of magical whatever. And she played the flute and they're doing some back and forth question asking. And she's saying, yeah, we're doing spells and charms. And then at some point, someone goes and starts the machine. So they have a lot of little rules like, okay, you should get extra points if you invite someone to start the machine. And so she reaches out to get somebody to pick it up. And then there's a whole sequence that happens there, all created by the student, right? Which is great. And there's, you know, different kinds of energy change and some electrical stuff. But they specifically have a rule against sensors. So that is what it is. Next, can we go back to the, stop this and go back to the, yeah. This is two of the teams, Circle Leprechauns, which I actually went to the homeschool group, and for 5 sessions, just 5 sessions, I met with them. And then they were like, oh, we're not going to go because we're not going to make it. But we convinced them that they should go, and they pushed through and did it. Team Gamer showed up that day and he wasn't going to perform. But I said, they're going to charge us $250 if you don't go. So they did it. And I have an adult team that has 2 students from Cal State, actually, not Cal State, one from LBCC and one from USC, used to be LBCC, but they're bringing in some friends slowly. I talked to their engineering club, so that's the 3 teams. The 3rd team hasn't yet competed. It's an adult team. Next. Let's see, getting close to the part where I go to what's going on now. Next.
Because this is
Yeah, Trish, we limit these presentations to 10 to 15 minutes.
Yeah, I don't think, how long have I done it?
Yeah,
Well,
20 minutes.
no,
but
we're about to 8 minutes.
Yeah.
8 minutes, okay, I can do it. We have a new opportunity. They had some challenges, global challenges, that caused them to have to cancel the international meeting. And so they asked me, and it was a short time frame because nobody else would take on the risk associated with it. But I knew what it meant for us is that we could leverage it to grow. So next, these are all the countries that backed out. So there's only Korea and US. Next. They told me up to 7 South Korean teams, and I have to do all these things, starting with 5 teams. Next. So there's a lot of problems, but there's a lot of opportunity. Next. I am going to, starting in the fall, because I know how to do this now, have multiple regionals. We had 9, 10 teams in our competition this year, including very committed people related to schools. One is in Huntington Beach. They did Mount Westminster, and that teacher is interested in going forward. So I'm going to help other people open up new competitions. I'm specifically reaching out to event managers and specifically the LA Maker Fair, because I've been there a lot, to host one next April. Their timing is right. And it's new opportunities for their funding as well as ours. I personally want to do this at Maker Fairs. So, and I'm looking to support principals and teachers. Next. So I said yes. Next. So the event, I have 14 K through adult teams competing at the historic Edison Theater. I received the keys May 1st, and then we're competing on May 3rd. I've got VIP packages, priority access to the competition, and a souvenir item that I will make, handmade bunny or mug. And then we have a stakeholders meeting with a VIP package. This will help to pay the bills. We have some sponsors. Bechtel donated $1,000. Raising Cane's donated $250. Birdwise Accounting, my niece's company, they donated $250, and we get some money from all the paid teams. But some of that money is coming from the Bechtel and Raising Cane's donations. So it's not a lot of money coming in yet. So I'm really relying on these stakeholders and competition packages. I've reached out to the LA Maker Faire folks, and they have told me that they'll network it. The Downtown Long Beach Business Association has said they'll network it too. Next. This is the historic Edison. Turns out it's smaller than I had anticipated. Next. So it doesn't really fit 14 teams. I need to find additional space near the Edison so we can start there and work to the next location. I need people to help me make bunnies. I need volunteers to help me during open times. And I don't know what else, because we have a budget we have to manage. And I think that's it. So this is the space, and that's a bunny. And yeah, there we go. So I know that the OC Maker Faire is interested in this meeting. I probably listens to it. If you're out there, OC Maker Faire, let me know if you want to have an event at your Maker Faire, and I will help you. But and then if you guys care to participate, it's not quite on the technological level as the robotics competition, but it certainly is highly creative. So thank you.
All right, thanks, Trish.
All right, do you want to do the banner now? And so you got the
Floor.
you got the
All right, welcome to our new banner. Yay! All right, this is done.
Thanks to the gracious donation and generosity of time from our very own Cal State Long Beach students who are,
her name is Vivian. And she is one of our student assistants here. And I just kind of mentioned, you know, we needed some design work, and she was like, me. I showed her a sample that we were playing with, and she ran with it and created this.
Yeah, so the whole point is 2 freestanding banners with an integrated base. So we'll get those ordered today. And then they just get stood up either behind or in front of the tables based on the event layout. Easy to pack, easy to unpack. Should last us for a few more years. And I think it'll come to like $300 or so for 2 of them. So well within our budget. We've gotten more than enough use out of our previous generation banners. So
Oh yeah.
yeah. I think it would be it's going to be a good investment.
Yes. This is much more representative of the club that we have now. And it actually has our branding and our I guess we could call them our mascot.
Yeah, our mascot, and you know, the kids use their QR codes now, so we got the QR codes.
Yes. Did we ever name him? Did we ever name the robot?
I don't know if you ever got a name.
I think we should name him.
Mascotty?
So if anybody has any ideas of what should we name the little mascot robot?
Bag of bolts.
Bag of bolts.
That's my first thoughts are usually good names, but
Right, that's better than masking and masker.
in the spirit of we always have boxes of parts and stuff.
Later.
Bag of bolts. Bob.
And
Bag
one
of
more
bolts.
time.
So his name is Bob.
There's some robot parts right outside the door that we need to find new homes for. So like Alan said, we're not taking any of that. So
that I need to be taking home somewhere.
Yeah, if you know someone, if you want it, take it. If you know someone who wants it, take it. If you have a place to hold it, take it, just take it.
All right, so, Thomas.
Hello. This is Rosie. Rosie the robot. And I don't know if I can give you a demonstration today because I just noticed the laptop is dead. It may have a little bit of power left. I'm gonna try it. I thought I charged it last night. I evidently, or maybe my battery needs to be replaced. I don't know. Anyway, to make a long story as short as possible, Rosie consists of a vacuum cleaner base. This is a bot vac from Meetup. It comes with its own LiDAR, which was very helpful because LiDARs are important when you're trying to avoid people, table legs, dogs, cats, etc. I put the laptop on the robot itself because I wanted it to be able to use AI. And currently the AI stack I have is a Whisper for voice recognition, Olama, and I forget what model, for large language model chatting. And what was the other one? Oh, Moondream. Moondream for object recognition and analysis. Basically, the task of this robot, what it has to do is roam around the room and offer snacks. That's all it's supposed to do. And I'm adding probably next month, a new feature that'll look around and see if there's people in the room and then go to people and say, would you like a snack? So let's see if it'll start. Otherwise, I just sent you a video through the club mailing list. Can you pull that up?
Oh, yes, yep. Give me a second.
Check the club mailing list.
All right.
But I was running around my kitchen. It never hit anything. And it goes from one end of the room to the other in a figure 8, and then swaps around a reverse figure 8. Covers perhaps 80% of the room, which is what I wanted it to do. There we go. That's my kitchen. It's running ROS, and I'm running ROS in a GUI. And instead of having 20 terminal windows open there, I've got them all within the GUI.
Oh, nice.
That's it. That's a short video. But so let's see if we can get this thing running. Well, that's funny. At first it said it says it's got 92%. Maybe we do have a demo. I don't know. Hopefully it's not. I'm using a GUI. This is Linux. And I did a double tap for a GUI. And
I'm in hard mode. I'm ready to go. Push my road button to start.
I'm going to turn up the volume on that. That's loud. That's as loud as it goes. I get a little bit of an amplifier on that. This is running ROS 2. Being a vacuum cleaner robot, it doesn't do very well with wires. So I'm going to have to push these wires to the edges of the room.
Why don't you use that part over there in the front? The handle right here. A lot bigger.
And what we'll do is I'll pull this to the right. To my right. I'll try not to. And then we're going to put some chairs around to so it doesn't run over the wires. Should be enough.
Okay. This is your mock bot.
This is
Is it a Neato?
It's a Neato based on Camp Peavy's mock bot. And Rosie is programmed for donuts, so we have to give her some donuts to give out. So we'll put the remaining donuts on her tray. And Rosie does have an LLM, you can talk to her. But right now, the primary goal is to get it roaming around offering people donuts. So it can just hit the green button. And it's gonna move slowly because I assume you're in a room full of people and you don't want it scooting around, cutting people off and tripping people. You say, oh no, we're gonna hit the wall. Oh, maybe not.
So this one roams without maps.
No mapping.
Where's this?
Luckily, it sees that. Oh.
Talk to yourself.
And it's going to do like a figure eight and then a reverse figure eight. Again, it covers about 80% of any room. I have a ultrasonic sensor under there that has not been added to the sensor stack yet. The sensor is down there on the floor. That's not working.
Oh,
Talk to yourself.
Oh, so it's using the built-in LiDAR there for wall detection and obstacle.
It's just looking to avoid things and following a pattern. Pretty simple.
Pre-programmed pattern.
And sometimes it does clockwise turns and sometimes it does counterclockwise turns.
Okay. All right. So,
Now it's doing the counterclockwise turn. Should turn all the way around, hopefully. Well, there we go. Now it's going the other way. And I got caught in that little corner over there. I don't know what's going to do now. All right, we'll take that.
Are you putting a path in there like using odometry, right?
No. No, strictly, if it's in front of me, I'm going to go left or I'm going to go right.
It's just obstacle avoidance mode.
Obstacle
But
avoidance.
how do you, like, how big is the figure eight, or is it not? Or is it just time based?
It's time.
Okay.
Depends how fast
Standard.
it goes. The faster it goes, the larger the figure eight.
You can change the speed.
I'm stopping. I will stay here.
All right, and so the only other thing I've got working is the chat mode. Takes a little time to boot and initialize. Today,
Chat mode engaged. Wait for the tone before speaking. How can I help you?
what do you got today?
Hold your horses.
Hold your horses.
First time through is slower.
Donuts.
all right. Okay.
Do you have anything else besides donuts?
Yes, that I'm busy.
Oh. How are you today?
Hold your horses. Donuts are being handed out.
Do you have the time?
Just a check. I'm here to serve donuts now. Chat mode is off.
Anyway, that's all it does. And I'm pushing this to be a product, something that you'd be able to buy, and it would go around your house serving your guests donuts or beer or soda or anything. The one mode I want to add to it before finalizing it is a sleep mode. That's the fourth button, where it would look for a person in the room, say, I see a person, and then go in that direction and say, would you like a donut? And if not, go in the opposite direction. And that's the product. That's it. I'm done.
That was the last one. Tell unless anybody else has anything else. Do you want to talk about contests?
Do I want to talk about conference?
Yeah, what happened to our contest?
Somebody bring up like email list because I published this email on that subject. Almost halfway through March, just before the March contest. And got one person sent coming back that was Bob here. So I don't know if anybody else has thought about this email. But if that hasn't, meanwhile, I'll just talk about it. Put it up.
Yeah.
The useful try line Friday, March 13th.
You will not find the web.
An email from me. Check your sense.
You see it?
Yeah, it's like two more.
Right
There you
here?
go.
Okay.
It's the best thing about it.
Oh, yes, I got one from you.
I got you.
Okay, now, did everyone here hopefully remember our most recent contest to have robots that would go and find and pick up a soda can?
Yes.
Okay, well, we had a lot of participants, which is really good. Now, since we have robots that have some kind of mechanical, I was thinking, maybe what we might want to do in future contests, we might consider adding to the robot's skills. So one way would be to increase the variety of object shapes that the robot would have to be able to grab and pick up. Here are some examples. A rubber ball would be difficult because it can roll away. But other things, like a box of breakfast cereal.
Are we talking about like a full box or the little single serving ones?
Or whatever, it doesn't matter, whatever you want, I'll leave it up to you. Coffee cup, I think if you want to, you could have, say, your extra points for picking it up by the handle, but a robot really need to do that? A household robot, maybe we should take that out. About extra points for that, because I don't really see any practical points, so you could.
Plastic cup.
And you can get extra points for, however many points, however many different object shapes the machine can actually successfully pick up and lift.
I mean, the clock,
You get extra points.
the clock can probably pick up the coffee cup from the handle, but it'll probably spill it because it's.
Oh, I'm not suggesting we should put any liquid in.
No, I know, but
I'm sure they're gonna tip over, you don't wanna make a mess.
yeah, it could probably do it with the claw, but I would rather grab the cup itself.
Okay, well, we can take that part of it.
All right,
So
so
another way we could go from what we've already achieved is to just mark something on the floor with something temporary that comes on. I suggested black electrical tape because I know it doesn't leave any debris. We pull it off later. And it's cheap. And you can roll it for a little over $1. You put the robot on the soda can, so without leaving this rectangle on the floor, the robot would have to pick up soda cans one at a time and set them outside. So that would be a different approach to add capabilities. And I'm looking for other ideas. What kind of a thing could we do for the next contest? Based upon what sort of robots we have and what we think we might be able to add. My second choice here, number 2, would require that you have some kind of sensor on the robot that could detect a black color on the floor.
So incrementally from what we had from the last one, number 2 seems like the most, I guess, closest to the next level, adding a sensor to detect the line and.
Yeah. Number 1 probably requires hardware changes for everybody's robot, right? And there's
A mechanical thing, number
Yeah.
one.
I also sent out an email. I don't know if you saw that one.
No, I didn't see that yet.
Yeah, it had three, and one was stacking.
Yeah.
And stacking seems hard. Same thing, hardware changes. So that's probably the toughest. The second one was a lot like yours, but I said the same thing, black tape, but you start with cans outside of the tape, find the black square, and then get them into the black square, so you can have a larger
I see.
place to start with.
I see.
The last one, so we're doing a lot of AI around here, would be like instruction following. Pick up the red can or the Diet Coke can, or put the two cans together.
That might be a good idea to do. Yeah.
Right, right. So those are some. I think that the tape one is very similar. Like we both came up with a boundary and moving things in or out of a boundary, and I think that
seems like the next step from what we had from the last one.
Yeah.
Yeah, I noticed, I think I posted on the board or replied to the email, but what was interesting is looking, I think like 14 years ago or 10 years ago, there was a contest at a previous location at Cal State Fullerton, I think. And it was pick up the can contest. And there were at least 3 robots that were the same. So, look at you guys. And there was another Lego one exactly like this. But anyway, what occurred to me is that, the AI stuff is really good. Unfortunately, Alfie didn't compete. That would have been a really nice thing.
Oh yeah, I'm going to keep talking. My hardware platform can do anything you can throw at it.
Yeah.
Okay, so I couldn't even participate in the last one.
Yeah.
Okay, minor setback. It worked at all.
So there's the mechanical challenges. There's like add an extra sensor and keep it basic. Or we could look at some of our previous contests. We're just building simple robots. We have a lot of line following. There's a lot of line following variations that we did. There was maze, the obstacles, things like that. So that's a possibility.
Yeah.
Just go back to.
And also, Camp PV and the Homebrew Robotics Society, they have a beautiful, long, tried and true list of challenges for both table bots and floor bots. Basically, you can look at that list. It's very, it's good, and there's challenges that a lot of us haven't even been able to do. And there's a maze one there too, but the standard tabletop, be able to, that requires sensors to avoid for cliff sensors. But you could also just do that on the floor and have the floor bot go across the room. You've probably seen these. Just go to challenges, and there's the AI challenges as well. I participated in these. I mean, I've never done maze stuff. That's kind of a neat thing. It's of navigation, but for entry level people, this is has been successful at that club, to bring them in.
So I saw a little further down the road with John.
And the arm one is there.
Since we do have the
I want to
now, why don't we plan not anytime soon, but somewhere in the future? Let's do our own little Rover Magellan.
Yeah, I'd like
to.
What? I got the website. Where is it?
I mean, we already have a domain.
We have the domain that came from one of our old members.
We could start out simple and just go from point A to point D with the GPS coordinates or something,
maybe it's kind of like that, right? So the Rover Magellan is point A to point B, but they put a cone there that you can touch.
Yeah.
Right?
Yeah, well, it's the obstacles, or we could say we'll do it without obstacles, because it's the random obstacles that are the real challenge.
Yeah, the first step is like just 2 cones with 10 feet apart or something.
The thing I didn't win Rover Magellan. The thing I liked about it is you can have progressive points, right? So you say if you get closer to it, that's some points. If you touch it, it's some points. If you touch the second one, it's some points.
Yeah.
There's ways you can make it so even if your robot's kind of coordinated, kind of goes to a GPS coordinate, you've got some points. That's nice.
So I would really like to set something up for that in the future. So that might take a little more planning.
Why don't we?
Yeah, that's
Why
bigger.
don't we
I've been working.
think about that. More for the future.
Yeah.
But for the moment, let's try to build incrementally.
Yeah.
Since we have roughly 6 or 7 contestants, if we could do something, it's a contest where people have minimal change because everybody's kind of busy in their own lives. Something that's It's not a lot, like very little hardware change, but something, it's just a little programming, and then we have some excitement.
Yeah, so I like
Well,
the,
you know, if we want to do that, and we want a really, really, really small change. One way that we can make a really small increment is, all you robot has to win is to pick up the soda can without ever knocking it over. Not even once.
Yes. That's not a big change.
That's not a big change.
I would suggest
That's what we did.
your tape idea. Start with some cans outside of the tape, right? Get them into the cave. Maybe have a rule so you can't drag them, so we make sure we're lifting.
Yeah, my old robot was.
And then one of the things so you can make it more complex. So like have so many cans that they barely fit in the square, right? So there's a good chance you're knocking things over, and there might be some strategy there to stop when you get.
Well, you know, we could go either way on that. We could have the robot start outside or inside. Go either way.
Yeah.
The advantage of having a robot inside is all it has to do is avoid crossing a line. Because it always stays inside. But if the robot starts outside, it has to have a pretty good idea of
It might have to
where
go,
it is.
walls
How to get
might be
back-
on
how to
this
get back
side
to-
and tapes on this side.
The
It
rec-
might confuse it a little bit there.
Anyway,
Yeah.
we could go.
That's true.
We did, one in the past was follow the line, and there's a can at the end of the line. So you just follow the line and pick up the can. So,
Or you
I
remember the one,
remember that one.
so was that?
I don't.
That was a while ago. That was Safe Force.
but
That was like the first can.
That was it.
Okay, I remember.
we also had the one where it was a 6 by 6 foot taped out square and with a small inset square where the cans needed to be returned to, the sort of waste.
Like a trash can area.
Yeah, trash can. You could use a real trash can if if your robot could lift it and put it in, but short of that, it was just an area. And so
You
then,
could slide it, if it's not a lifting robot, it could slide it to.
yeah, mine slid, my old one, you've seen the video of mine, it would push, but you could make the requirement to lift. But then it would, and you can always follow the robot is allowed to maybe go onto the line and follow it back to the waste bin if you
Right,
want as
yeah.
well. You don't have to do full dead reckoning even, right? Because you know that if you follow the black line, it will lead
Get
to
the
where the
trash can area.
trash can area. And you could put like something there if you need a little extra, like a color or I don't know, a double line, something that would, if it's too hard to figure out. Or you just detect you have one sensor, you could detect the line, the inset line, and then you go, oh, I'm inside the trash area or near. Anyway, but that was one that seemed to be pretty cool. That it's just a variation of what you're talking about. Is moving cans to a particular area, but just moving them outside is also is one way. But then the robot has to remember how many times it's crossed, so it's a different challenge.
Or if it goes, here's the corner and it crosses this line and that line, now it's going to be confused.
Yeah, we have to have logic in there to count.
Yeah, right.
And then if it gets confused, you can always find a line and go back, follow the line until you hit. We have some, if we mention everybody has a side sensor. Well, if even not, you could do something where you change the color or you make a little break in the line. So then right where the box is, the inset box, so that even if it gets lost, it can follow the line till the line ends and then it knows so there's a break and then it knows it's there. It's more simple calibration type, giveaway type thing or hint,
Those were all good ideas. Thank you for all thinking about this. That was my objective.
We might still have the rules for that one where it's we call it the trash can contest, I think, and one is either put it in the rectangle, the can in the rectangle, or throw it in the trash can or whatever. But we might have that rule still online on our.
Yeah, it's called Clean the Room.
Yeah, clean the room. There.
Clean the Room is there. That's the one I'm talking about actually. So I guess I forgot to just you can just bring it up on from our website.
Yeah.
And I'll just mention one more old one that we did a couple times, and it was just a a grid of lines. So it was just like a, like a piece of graph paper, I don't know, it was 5x5 or whatever. And at the contest, each node had, A1 or A2, we had letters and numbers to name the nodes. And we'd say you have to go from, A1 to, B3, and then it would be up to 3 bricks in the way, blocking some of the path. So you had to follow the lines and then sort of plan a path. And then the sensors was using cans are just forward-looking ones. So you use the same type of sensor to say, oh wait, there's a brick, I got to turn around and go another way.
Oh, of course.
Yeah.
So that was
What's nice about what this particular one, because some robots are using ultrasound. So if you have a 6-foot area you're working in, and people can stand at the 8-foot area if they're using 2 foot as their, as their point of don't run into the person's leg. Something. Anyway, that's kind of what that one shows there. That one seemed to be very successful. We had 3 or 4.
And this seems like a good extension of the last one. So this seems
Yeah.
like a good one. Like I wouldn't have to mod my robot too much to do that, right?
Yeah.
Jeff, sensor or two.
Most people who do this.
I had to downgrade from this to the main,
Yeah.
or I actually had to add lift.
Let's plan for this then.
Okay.
Sounds good to me.
Another, couple of months?
Wait a few months.
What do you want? You want July?
Are you good to July? Yours is the most advanced, probably.
Well, but yeah, I also didn't work at all and I was planning on a hardware refit. Yeah, you guys decide when you can safely do it and I'll make it work, or I just still try. July?
Are you gonna do it?
Yeah.
You said last time you were gonna quit or something.
Well, you've already
that's
succeeded.
easy.
Yes.
You succeeded that one time. You moved cans into that.
Yeah.
I remember you doing
that box.
I it's on the I have videos of mine pushing, so now it's gonna lift.
Well, I mean, I looked at the rules here and you get points for lifting, but it's not required.
Right. I could convert the robot back, but might as well use the lift. Oh, you get extra points though. Right?
It's funny, the score sheet doesn't have it, but the rules do have it.
Oh, really?
How it did.
I didn't think there was any
Okay, maybe
lift
not.
in here.
Bonus points if robot actually picks up and drops cans into a real trash can.
Right. Bob did it.
Small point of order though. Apparently there's a 2-foot perimeter around the 6-foot square box. I would like to point out that means that the outer perimeter is 10 feet and not 8 feet.
Yeah, we can make it.
No, 2 is, hey, dude.
That hallway, I don't know how falls like that is.
Huh?
I think
We got
that's
10 feet over here.
sure.
Actually,
You're right there.
And
Violation
violation is just the wrong word too.
If not, whatever, we can fit in the hallway.
Perimeter would be.
Well,
eight
it's nice
feet.
to know.
10 foot, my arms reach
40.
about 2/3 the way across. So yeah, it's about 10 foot out there.
Okay, we can do that.
Oh, so it would work out in the hall.
Mhm.
Yeah. All right.
Yeah, I could, I would participate.
Let's see, July is 3 months from today, August is 4 months to today. How much time do you guys need?
I'm good with July.
Oh my
I want
God.
to ask about this real trash can. It's okay, it's like that tall.
I'm thinking it to be.
A lid or something, just something you have to force you to
It's bigger than the can.
So you can bring your own
A
trash.
2-foot can is gonna be hard to get into, but like a small little, something where forces to lift.
Right, because you don't have to lift as high and all
You
that.
can 3D print your own little. No.
Yeah. Like I said, about that tall. just
Specify a minimum height or maximum minimum height.
No, just whatever your robot can do.
If it forces lifting, right? That's
Yeah.
like, that's a big deal.
Yeah,
Here's
the
your own trash can. That way you solve your own problem because we can't specify that.
Yeah, here's the
Yeah,
here's the
she'll
rule
buy
of thumb. If you are in good faith attempting to accomplish the rules of the contest, it'll probably go. If you're going out of your way to stretch the rules to the breaking point to prove the point, then yeah.
Well, I think of a rubber bait, we
People
have
you
a
out.
trash can, but I think it should be okay.
Yeah.
If we agree, then it's okay.
That you're on what? Oh, just.
Take a rubber bait, let it turn upside down, now it's a trash can.
Yeah,
It'll
it's the
hold
point
stuff.
where if the lip has to be 2 millimeters versus 4 millimeters, that's the wrong conversation.
We don't usually get that.
Well, no, but I thought a real trash can is what, like 2 feet tall, and that's gonna be real tough.
Yeah, Bob did it with his arm.
A little one that.
How was yours?
Well, yeah, because he's got a really giant robot.
Yeah.
You want to put in bonus points for the height of the lip of the trash can?
Sure.
Oh my goodness, I have to bring back the forklift mechanism.
That's right. You were doing the
Yeah, it got too complicated. I had to remove move the sensors because when the forklift was there, the sonar would interfere if it had anything in it.
That's what happened to me. That sonar always gets interfered. It interferes with your part of your robot.
Yeah, so I switched to the claw just by the servo. But I still have all the plans and I printed all the pieces for it.
Wait, but did you participate last time? Yeah.
Oh, yeah, everyone except for me. So Danny has a good point. What if your robot is the trash can?
It's like, yeah.
All right, guys. Sounds great. July, we'll put it on the calendar. I'll update the website, and with any luck, Alfie will be able to participate.
Yeah, July.
Hey, Alfie.
And remember, free robot parts outside.
Yeah, it's all got to go. If you know someone that could use it, just grab it.
Yeah, if there's any leftover Legos, I'll take whatever's left.
I'll take those. In that case, 2 big boxes of,
Did it?
I don't, can I have those 2 big boxes? Sure. Yeah, I'm taking 2 big boxes, guys.
Perfect. They're all yours.
What are you asking?
Oh, thank you. Glad you're able to make it.
Come back next month.
Yeah, I'm gonna try and check out the.
Be there.
Yeah, it'll be fun. We've got a booth. It's an all-day thing. I didn't bring any hardware this month, but normally a couple of us bring whatever robots we're working on. And we all just like hacking stuff.
Stumpy the quadruped will be at the Baker.
Where do I start, I guess? Between your talk and Jim's talk, I was very lost.
Don't worry about it. If you've never done anything robotics, a good starting point is Arduino. There's a ton of Arduino kits that usually come with a whole bunch of experiments that you can do with them. That incrementally get you further. Yeah.
Yeah, Amazon, find the kit that resonates with you, spend a couple of bucks, bring it in, and you'll pick it up really quickly, right? Because I don't know, like, you don't even know, like, you're more passionate about hardware or software or electronics for wiring and this and that. It all kind of comes together, but it is not like, when I was your age, it was a whole different world. I can't believe I said that out loud. But it's just awesome. Just find, spend 20, 40, $100 if it's a walking robot or a wheeled robot or an Arduino kit. It really doesn't matter if you're the first one. Just find something that looks like fun.
And how far are we from like all the interactions I'm seeing between human and robot speaking? It seems like it's not very close. Are we closer?
We are close enough that some of the most well-funded companies in the world are dropping hundreds of millions of dollars in developing hardware, waiting for the other shoe to drop with the software side. And it's no longer, we don't have a path to it. There are teams working on the low level and teams
And then I was
working on the
a
higher level topics.
mentor or coach
And it's
for
just
the
a
little
matter
guys.
of between university, private, the tools are available, and much like how OpenClaw is not revolutionary. I mean, not that Anchor's awesome, they're smarter than I am. Yeah. But it just took that one person, a retired, engineer, a weekend of vibe coding to show the world that we already have the tools for.
Well, I'm
We just
just go, I can't, I already.
Okay.
Yeah, thank you though, I just want to say it every time, and I do love those events.
We're trying to get out of here.
Yeah, and all of those going everywhere is so fun.
This year's chaos.
Yeah, we'll
Okay, yeah.
All right.
So anyway, have a really good time. Showing up.
Yeah, we'll be here for a few minutes.
I don't know. You can bring it in.
Yeah, I'll
either.
Yeah, but
every
single guy, because all things they learn.
I designed and built it in like 2 months last year. And Once I can figure out. It just took a couple hours of training data to find and pick up and shut down code camps. That's like the process.
Get one of those,
And what I'm doing now was possible 2 years ago.
Not
It's
if,
just
they're like 20-minute.
waiting for those intuitions. Oh, if you do it this way, it works better. That's it. But yeah, this is not the year of the humanoid for me. I'm keeping my credit card in my pocket for now, but probably next year. Yeah, it's really hard for me not to talk about the $20,000 one that they're offering right now. It's not quite there. Well, I got a Go-To and I wanted to buy a G1 and I've been waiting for the R1. They've locked down everything now, so it's not like they used to.
The robot dog will be at the Maker Fair, so if you come, you'll be able to see it.
Oh, yeah, I'll bring it.
The Go, or no, yeah, the Go 1 or G1 or whatever it's called.
Works for Levon.
You know what I'm talking about, right?
They're ahead of us with that answer, like the other earlier.
It's
They have
like.
4-legged, 6-legged action robot. But he shows me, it's chilling. He
Yeah,
said,
you saw it,
it's
yeah, so he has one, so we're gonna bring it in, we drive it
They
around,
opened
we
the
drive it.
truck side.
It's a lot of fun.
Like 20 of these.
I was like, I'm walking around like, and try to hand out business cards for years, to try to get interest and stuff, so, yeah.
Does the club work on this together, or is it a lot? Do you guys work on things together, or is it a lot more?
And now Lloyd's gonna help me.
I'm gonna
Yeah.
Good robot. Fun. I think it's like each person has their own kind of like interest. Like one person's really into this and one's really into that or whatever, right? So I feel like sometimes, enough people left. I feel like sometimes it's hard for people to find like their exact
stronger last name.
You know what I mean? But I think that would be cool. I would love for us to have a day where people just kind of bring what they're working on, but also sometimes people need their home network, that kind of thing. But there's a group called Makerspace maybe, or maybe not. They're the same guys behind the Maker Fair, the OC Maker Fair. And they have a makerspace that they've got. It's in Fullerton, I think, and they have meetups. Actually, you should look that up. It's on meetup.com.
Okay.
And they also have a Discord, and they're more active in the Discord, but I'm not in their Discord. I just do the meetup. So they have meetups like twice a month, and it's free to come. You can just show up, you can meet people, you can see what people are working on. So that could be a thing too, to bring a project you want to work on, any kit like you were talking about. That's how I started. I bought a $50 Ellen kit, which is like a little robotic car, and it came with like all the wires. It was pretty straightforward. It was like you could see the slot where the wires went, but you plug the whole thing in. But by doing that, you learn exactly what goes where, why on the controller board, on the like the H bridge board, whatever the one they had the license on the front. That so you can download the code and just have it like avoid obstacles like walls or whatever. And I learned so much just from that project, and it was so much fun. It's really a simple project. And then with that, you can download all the different codes that are available to have the different things: line following, wall following, object avoidance. And then also now with like the AI stuff, you can just have it like, I want code that does blah.
Yeah.
And then there's so much variety and there's so much you can do, even at entry level, even at there's so much you can do. There's so many sensors and little parts and all these cool things to do stuff with this.
What was the name of the car, and what was the name of the?
The car that I got is
Spell that.
ELDGOO. I think. It's basically like a knockoff Arduino type brand, but they make a lot of stuff, and they have like a little remote control car. You can also control it by your phone. Yeah. Yeah. You see, but I no worries.
That's like the same family.
That would be different. So I got that guy, and I love it. It's so much fun. And then the meetup is let me grab my phone because that would be easy. Yeah. I never remember the name of stuff.
Yeah, that's been working. That's so far it's okay.
Okay. Oh, sorry. It's not called that at all. It's called 3D printing or 3D printing orange now. 3D printer. And then, so they have, let's see, they have events, they have one, well, today, sometimes they overlap with this. And then they have another one, and they're all really nice, and I try to go to that sometimes, like it doesn't interfere with this. Because that's my priority, but they sometimes come here as well, and, it's really cool, chill, people who are really into 3D printers, really, they have, like, I don't think that you can just show up and like use their machines or anything, but you can bring projects and talk with other people and learn different things. And I I have an older 3D printer, and I brought it in one time, and they were helping me figure out stuff that was wrong with it and things. So it's a lot of people that want to share their joy of this, so they're willing to like help other people with any problems they might have or questions, or everyone's like sharing information and stuff like that. So it's a really good group. Yeah, they're really cool.
And then do most meetings kind of go like this, where it's like two?
Yeah, so usually there's two talks that are 50 minutes, and then usually show and tells after. That's the general like theme of it, the way it's supposed to be. That's overall how it usually goes, and they vary. Sometimes we have this other guy, Ethan, who is also in that 3D group. He does kind of sometimes more like beginner-ish, like not super beginner, but like learning about Raspberry Pis. So he'll be like, here's a car I made with Raspberry Pi. Here's what I'm having it do. It's gonna, pick this up or whatever. So he does stuff like that, and he'll have talks like that sometimes. So it just sort of varies of the the levels and stuff, but it's like even if you I don't know aren't understanding like all the things, there's still plenty that I don't understand, even though I've been coming here for years. But like you get familiar with the terms, and you get more familiar with a lot of the stuff just by showing, you know what I mean, just by being around it, even if it's not all like immediately apparent. A little bit of what we're gonna do is we gotta turn this back into this shape, except for this rose. But this is really green. Yeah, so if you.
Well, we passed the one.
Oh, thank you. Yeah.
Move this guy out of the way so that we can. Yeah, pretty good. How about you? Haven't seen you in a while.
Trying to make more of the meetings.
Nice.
This logged in this morning.
Oh yeah, he had to send a second link.
I know, and I was always
This one we just leave it.
And I'll get to make a square.